Hey friends, welcome to my YouTube channel, Nation Labs. Myself, Rahul. Today we are going to see one of the important topics into the NLP back of works, and one of the I'm going to focus on one of the topic that is called as document similarity, or we can say vector similarity. As you know, the natural language processing is one of the upcoming topics that we are using everywhere in our day-to-day life, including the recommendation systems, finding the contextual speeches, searching of the new similar topics for the research, as well as plagiarisms. So these are important topics. This video will be in the English as well as in Marathi, and let us see the concept step by step. So first step, we are going to see the concept of bag of words with NLP and that document similarity process. And then we will follow a code snippet, and I'll explain you the code. And then we are going to look into how we can visualize the document similarity. We'll go step by step. Hey friends, so let's see into step by step. This is my GitHub repository. You will find all the details, including program here uh, for the BOW, bag of words concepts. This is a very small example just for the understanding of the, at the primary level. The bag of words मध्ये सर्वात पहिल्यांदा आपण पाहूया. अं, सर्वात पहिल्यांदा इथे दोन फाईल तुम्हाला सापडतील, रीडमी फाईल आणि माझी कोड फाईल. यामध्ये माझे डेव्हलपमेंट एन्व्हायरमेंट आहे व्ही एस कोड ॲप्लिकेशन्स पायथॉन व्हर्च्युअल एन्व्हायरमेंट, आणि यामध्ये एस के लायब्ररीज, एन एल टी लायब्ररीज आपण वापरणार आहोत. So the key concept here I'm going to explain, and moreover I'm going to focus on the main concept with the TF-IDF, that is term frequency, inverse document frequency, and cosine similarity between the documents. So let us see what is documents and what is the similarity. So friends, let's go one by one. If you see the bag of words concept, as we know, it is we can consider as the bag of apples, bag of toys. Like it is similar to like a bag of peanuts or something. So similarly, we have a bag of words. Uh, why we are going to extract and mine these words, आणि त्या बॅग मधून आपण वर्ड्सचे अनालिसिस करणार, त्यांचा कंटेक्स्ट फाइंड आउट करणार, आणि त्यानंतर आपल्याकडे जे मॉडेल्स आहेत एन एल पीचे, त्यावरून आपण एक कन्क्लुजन घेणार. आता यामध्ये तुम्ही पहिल्यांदा जो फर्स्ट पॉइंट आहे बॅग ऑफ वर्ड्स, इट रिप्रेझेंट टेक्स्ट वर्ड फ्रिक्वेन्सी वेक्टर. Vector, as you know, what is a vector? It has value as well as direction. त्यामुळे नंतर आपण BOW मध्ये आपण स्टेमिंग करतो, वर्ड्स स्टेमिंग. आपण इंग्लिशमध्ये जी वोकॅब्युलरी बिल्ड करतो त्यामध्ये आपण लाईक एंड, एंड्स, एंडिंग, त्याचं आपण स्टेमिंग केल्यावर आपण एंड या कन्क्लुजनला पोहोचतो. लेमास, लेमामध्ये आपण we are going to find the similar contextual words or the similar words that plays have equivalent contextual meaning. तर त्याच्यामध्ये लेमा आपण असं इंट्रोड्यूस करतो. तर या गोष्टी आपण ह्या व्हिडिओमध्ये कव्हर नाही करणार. या व्हिडिओमध्ये आपण पाहणार आहोत. आपल्याकडे एक टेक्स्ट आहे, ते आपण टेक्स्ट वेक्टर्समध्ये डिवाइड करणार. वेक्टर्स इज नथिंग बट वन यू कॅन से अन ॲरे ऑफ वर्ड्स. तर त्याच्यामध्ये आपण 5-6 वेक्टर्स घेऊ, आणि त्या वेक्टर्सचे आपण एक्झाम्पल्समध्ये आपण ही पडताळणी करू की ते वर्ड्सची फ्रिक्वेन्सी काय त्या वेक्टरमध्ये, आणि त्यामध्ये त्या आपण एक वेक्टर त्याला आपण डॉक्युमेंट्स म्हणून येते. त्या डॉक्युमेंट्समध्ये आपल्याला काय सिमिलॅरिटी भेटते. म्हणजे आपण बरेच सोशल मीडिया पोस्ट पाहतो, आणि तिथे आपल्याला दिसतं की almost two users have used similar um, terms of the words, usage of the words. Then how it comes to similar posts, and as well even the bag of words is used for dictating the sentiments. Sentiment is in the same, is it a natural emotional point of view, or angry or aggressive point of view, or something sarcastic point of view. So you can derive on the basis of the analysis of the words, you can derive the sentiments as well. तर आपण ह्या गोष्टी इथे कव्हर करणार नाही आहेत. तर याच्यामध्ये आपण पाहूया तिथून डॉक्युमेंट टर्म मॅट्रिक्स काय असतं. त्याच्यामध्ये आपण रोजमध्ये रिप्रेझेंट करतो डॉक्युमेंट. डॉक्युमेंट इज नथिंग बट द वेक्टर ऑफ वर्ड. त्याच्यामध्ये कोसाइन सिमिलॅरिटी काय कॉन्सेप्ट आहे, आणि त्याच्यानंतर आपण TF-IDF कडे वळूया. Basically, I'll show this is the code. You find this particular into the GitHub. So we have taken some vector. Okay, so these are the word vectors. You can say given the name large talks. So once we say this is a sentence, we are going to break down into the tokens. आणि त्यानंतर आपण सगळे जेवढे डॉक्युमेंट्स 1 2 3 4 5 मी इथे 8 डॉक्युमेंट्स फॉर एक्झाम्पल घेतलेले आहेत, आणि बिलॉंग टू डिफरंट कॅटेगरी. हेल्थकेअर आणि स्पोर्ट्स चे जे कॉन्टेक्स्ट आहे तो कसा ओव्हरलॅप होतो, टेक्नॉलॉजी आणि हेल्थकेअर याचा कॉन्टेक्स्ट कसा ओव्हरलॅप होतो, स्पोर्ट्स आणि कुकिंगचा जो कॉन्टेक्स्ट आहे तो कसा ओव्हरलॅप होतो, आणि असे वेगवेगळे इंटरलिंक्ड कॉन्सेप्ट ओव्हरलॅप करून एक डॉक्युमेंट्स बनवलेले आहे. तो आपण यांना वेक्टर्स म्हणू किंवा डॉक्युमेंट्स म्हणू. Okay, friends, let's understand one by one the concept. I'm going to show. So, what is TF? TF is, we know, that's term frequency. It means the words that are appearing the number of times into a vector. एका वेक्टर मध्ये एक काही शब्द जे appear होतात आणि रिपीट होतात, त्याला आपण टर्म फ्रिक्वेन्सी म्हणतो. वाय दिस इज इम्पॉर्टंट? बिकॉज द reappearance of some words are going to stress the importance of the word into the context of that speech or that document. Am I right? तर एखाद्या वर्ड्सचा आपण ज्यावेळेस एखाद्या वेक्टरमध्ये एक फ्रिक्वेन्सी ऑब्झर्व करतो, त्याचा इम्पॉर्टन्स आपण ऑब्झर्व करत असतो. Similarly, IDF inverse document frequency. Why it is called as inverse? It's very simple. आपल्या स्पीचमध्ये किंवा डॉक्युमेंटमध्ये there are some words that are going to occur again and again, but it does not participate into the importance of the context of the document. That हे जे words आहेत, like for example and so, right? So or these are these are present into the speech or documents in huge number, but they do not contribute. They should not impact uh, uh, into the context of the speech, right? But like plain, there is a plan, reading, apples, or the some nouns. So these are the appearance of these words will contribute to the context of the document and the speech. So this is the concept of TF and IDF. So considering both, like we calculate, the method is to calculate the TF-IDF score. Means when there are some words which are pairing and are important words that give take us to some conclusion or some kind of understanding from the speech or document, and that is a positive score. So that should lead to the positive score. Okay, that gives weightage to the speech or document, right? So the TF frequency, turn frequency, positive score मध्ये, that is more the context, more the frequency, more the turn frequency, right? Inverse document frequency means in various documents, वेगवेगळ्या डॉक्युमेंटमध्ये ज्यावेळेस वर्ड्स रिपिटेटिव्हली असे वर्ड्स अपिअर होतात जे कंटेक्स्ट फॉर्म करत नाही. Those are not meaningful, right? And those doesn't those doesn't take us to some meaningful conclusion. But they are huge in numbers. So, annual document frequency, we have to take the low score, that is negative. The scoring has to negative, and combining the TF-IDF, this particular overall score, because but annual document frequency words do matter into grammar of that language. So that is also important, right, in some context. So TF-IDF, both considering, forms a new score, that is TF-IDF score, which gives us importance of the words into that speech. Hey guys, let's see the what is the concept of cosine similarity. So similarity is finding out the similarities of the two documents. So we calculate with there is a formula of cosine similarity. So let us take two vectors, and if you can say the two vectors have the context of apple as well as basket. So one vector is there is apple, another vector there is basket. Then there are documents uh, that are going to contribute with the apple basket both. So there is some kind of similarity, right? Uh, this is how we find the similarity within the document. So constant similarity help us to find the uh, similarities, like is the particular speech or is the sum of the speeches that that includes the speech of governance, if that includes the speech of economy, or if that includes the speech of if the context of some market or Sensex or um, some investment policies there. So this is one of the example I'm trying to explain where we have there is a vector which has an apple as well as basket. So what is the similarity between them? So here, if we see, we have a code here. So we must see there is healthcare focus sports overlap. Okay, so these are the documents that their context overlap to each other, and our target is our problem statement is to find how much similar these documents are. Hi, so let's see. This is the first of all we are going to determine the TF-IDF score for all these documents over here, and let's check. So for that, we are going to use one of the scikit-learn picture extraction. As we know, bag of words is nothing but the concept of feature extraction. We are extracting some features from that, and we are going to use this library. And basically, what it does is TF-TF vectorizer. It creates a vector among from the words of this documents, and this is the setting that we are going to use the English stop words, okay, to detect the tokens, and we are going to make it those um, tokens lowercase. I'm interested to find the meaning of all these words that should have at least you know only that includes words from that at least two times. Okay. Yeah, at least in the two documents, those words should be present. Okay, well, otherwise it doesn't make any sense to find the similarity, right? And exclude words that appear more than 80% in order to to go into the more over context of that one. So I have collected these documents, and I have trained this model to get the feature. So this is the name, this is the feature. What is out, and convert this vector to the data frame. Here we will see the data frame. Okay, so I print the column feature column feature as columns, and let's print this data. Okay, so I'll run this one, and it has run. So after running, you see this is the document, right? Or like technology focus, health technology plus healthcare focus. Now, if you see, these are the words that it has found, right? AI algorithms analyze athletes, right? Machine improve patient plans, right? Then specific, we had documents that has context of sports as well. You see here, like athletes, if you see. So uh, yeah, so like athletes, if you see here. Okay, so this document 4 has that mention. So how many times the word is involved into some context of the document? So we find the overall score for all these documents. So for example, if we take the plans here, this is in the plans. There are 8 documents from 0 to 7. So what is the score of these plans? So these plans, so there are plans in the document context 2. The document context 2, like let's see, this is context 2, 0, 1, 2. So healthcare focus. So it is talking about the plans. Similarly, we have the plans for maybe sports or achieving uh, something. So what is overlapping is health plans for the health, plans for the sports along with the health, the diet, like that. So here we see this is the total TF-IDF score. So it tells us the importance of these words into the overall complete document set. We call it as vector. So this is the impact, like analyze and patient. So these are the impacts of these words for this particular vectors. So how this score is going to be useful to find the similarities between the documents. Let us see into the next topic. Now, friends, let's go and see how we can visualize this TF-IDF matrix heat map. So I have plotted one heat map with the help of graph matplotlib, and I have used these vectors and going to see into the calculate the cosine similarities as well as like how we have uh, here if you see important words based on, so these are the important words we have found, and we have calculated how the TF-ID score is plotted here. If you look into this, you'll find, so you look into this, these are the documents, right? These are the vectors. You can see 0, 1, 2. So the documents 0 to 7, that is, and this is the emphasis of these words that are used, right? So like yeah, like if you say that analyze, analyze has impact. This word has impact in these documents, right? So for example, in the 0, you can see learning is the more emphasis. Then 0.51 is athletes have major impact in the document. 4, 5. So this heat maps as you go to the darker side of this color to the red one, and if you go to the faint brown, you will see the impact and importance of these words into that document. Hi, let us see as we have discussed the the cosine um, similarities here. Okay, if you see um, this one, right? So we are going to find the similarities between the two vectors. So how we are going to do that? Here is the code. That has helped us to find out the cosine similarity. So what is cosine similarity? It is a method to detect the similarities between the two concepts, two speech, or two documents, or two vectors, right? So we have, I'm going to use one of the scikit-learn library, matrix pairwise cosine similarity. So this particular function help, I'm going to pass this all vectors, right? All these vectors to find, and I'm going to take one by one and find the cosine similarity, okay, and then print. It is entered as the data frame, and I'm going to plot one uh, heat map, right? So let us see how what are the results that I'm getting. So I have plotted one 8 by 8. We have 8 documents. आणि या डॉक्युमेंट्समध्ये तुम्हाला पाहायला भेटेल की this is the same matrix. The doc 1, we see there is 1 1 for doc 2, for doc 3. It means there is the one indicates the positive correlation. It means those are perfectly similar, right? And if the value is 0, it means they are not similar. Uh, the document. So document, for example, if you take document 3 and document 2, so there is the vector similarity is almost 0.53. If you take one of the example like document similarity for document 1 and 2, it is 0.6. So this is how they are similar. To visualize and understand, this graph will help you. डॉक्युमेंट सिमिलॅरिटी किट मॅप. इथे तुम्हाला डॉक्युमेंट्स 8 पाहायला भेटतील आणि इकडे एक्स ॲक्सिसवर 8 डॉक्युमेंट्स पाहायला भेटतील. मित्रांनो याच्यामध्ये तुम्हाला जो डार्क ब्लू कलर बॉक्स देतो, those are most similar, and those who are in the white boxes, those are not similar at all. Okay, so document 7, document, if you see here, this is these are much darker. You can see document 6 with the document 5. Okay, so there is similarity of 0.6 for document 6 and 5. There is similarity of document 8 and 1 with 0.38. Right? You see, this is how it is color, and like there is similarity between document 2 and this is why we have taken this how we have intentionally took the context overlap documents so that we can identify the uh, similarity of the vector. You see, and this is how it helps us to find the similarity of the vector. Here in this context, we call it as a document, and the darker uh, area in this heat map shows more the darker uh, boxes. It shows more is the similarity correlation between those two documents. Here, if you see 0.289, that's a document 6, have only this much similarity with document 7. So like that. So this particularly is an exercise to understand uh, the document similarity and the applications of bag of words, cosine similarity, TF-IDF, IDF. These are very important concepts, and I hope you understand the application of this for the real world applications here in our day-to-day life. Also, we can observe like in market analysis. It's one of the best example of the uh, bag of wood. Like if there is a purchase of milk products, then there is a purchase of bakery products as well. So this is one of the very good example of BOW. I hope this particular exercise it gives you insights, little insight of the importance of the bag of words into the machine learning. So I hope you have understood this, and I request, if you like this video, you can follow my channel, like and subscribe. Thank you very much.